Hi everybody, I would like to continue problem solving process. Tension and compression. Last time I've showed some selected problems. In this video, I would like to tell you some other problems. The first problem for this video is example 1.3. In this example, you can see a cylinder. Cylinder is like this one. Mainly it consists of cylinder body which has thin wall, and upper part and lower part is covered with very rigid one here, and on the bottom very rigid plate as well. Okay, we have some dimension. External force P is given like this one. And external force P is 140 K here, kilopound. And length is given, and outside diameter T2 is 6, and inside diameter 4.5 inch. Poisson's ratio is normally 0.3, and modulus of elasticity is 30,000 KSI. Our problem is our question is first, shortening delta. When external force is given like this one, P is given like that, then if total system, the cylinder is elastic, we assume it's elastic. If it is elastic, total length L is changed. Then first, we would like to know shortening. Okay, in order to find the delta value, then we can apply some formula. We can think of sigma equals E epsilon. This formula we can apply here. This one is sigma, and this was strain, and strain epsilon is normally given change of length, and original length is divided by. Then we can have some clue. If you calculate epsilon value, then you can find delta value. And in order to find delta value, we must calculate sigma. Sigma equals given by P over A. Okay. Then we can calculate P, and P is given, and A we can calculate. Then actually we can find epsilon. And if you know epsilon, then finally delta value. Let's calculate it. At first, cross-sectional area here, because sigma equals P over A. We must calculate A. A value is like this one. A equals 5 over 4, and the outside D2 squared, and D1 squared. Then you can calculate A cross-sectional area S here. Then we can find sigma value. Next, we would like to know epsilon. Epsilon is what? Epsilon is sigma is divided by modulus of elasticity. We already calculated sigma value, and this value can be substituted this position. Then we can calculate epsilon. When we have epsilon value, it doesn't have any dimension. and dimension. It's just a ratio. Then we can find epsilon value. Then we know epsilon value, then we can calculate delta. Delta is what? Delta equals epsilon L. We know L value here, and epsilon is known. Finally, you can find shortening delta. Shortening delta. Why is shortening? Because external force is compressive force. Normally, in the mechanics of materials, this kind of compressive force is expressed in minus sign. In the case of tensile force, it can be expressed positive sign. Okay, then we can have shortening delta by applying these relationships. Okay. Next, lateral strain. In the case of lateral strain, when you try to find the lateral strain, we can think of Poisson's ratio. Okay, Poisson's ratio nu is defined by epsilon and epsilon prime, the ratio epsilon and epsilon prime. Then we know epsilon value, then Poisson's ratio is given 0.3, then epsilon prime can be calculated. We can get epsilon prime. Maybe this value has some value of minus sign. Don't worry about too much about minus sign. If we have minus sign, then it means contraction. Some kind of squeezed shape can be watched. Okay, you can calculate lateral strain epsilon prime. Then this one, increase in delta D2. Can you remember this relationship? Epsilon is what? Change of length, delta L over original length. Okay, delta D2 means outside diameter, this one, outside diameter. Then this one is given delta D2 over original D2 equals what? Epsilon prime. Then we can have D2, delta D2. Same process when you apply delta D1 over D1 equals also epsilon prime. Then you can find D2 and D1. And finally, we would like to know increase delta T. Delta T is actually here. And when you draw cross-sectional area, it's like this one. Outside D2, inside D1. Okay, this one is D1, and outside is D2, diameter D2, let's say D2. Then thickness, when you consider about thickness, is what? D2 minus D1, over 2. Main focus is this value. Don't forget this one. Then finally, we can get increase in delta T. Okay, in this problem, we dealt many things, but basically just apply sigma epsilon relationship and definition of stress and strain, or Poisson's ratio definition. When you apply this one, then you can finally get every question, answer for every question. Okay, that's it for this example. Okay, let's move to next example. In this example, we have a punch. This one is punch. This one is punch. Okay, this one is punch. Punch is given like that. You can make some kind of a hole there, or there, there, or there. With this punch, when you give some force, external force P like this one, then you can make some hole like this one. External force is given 110 kilonewton, and diameter is 20 millimeter, and this material's thickness is 8 millimeter. When you deal with this kind of problems, kilonewton, be aware of kilonewton, that's different. Okay, our question is average stress in the plate. In the plate, we would like to know average shear stress. Next question is average compressive stress in the punch. Okay, let's think about both problems. First one, average shear stress in this plate. When you draw this area, and big force is given by P, and some small forces are acting like this one. Okay, actually shear stress is given by some forces is divided by shear area S. Actually, shear area can be like this one. This area is shear area. When you draw it again, it can be like this one. In this area is shear area. Okay, then this one is what? Thickness T. This area is AS equals what? AS equals phi d T. That's the AS. Then shear stress tau, average shear stress tau equals P over phi dt. Of course, we have Newton per or kilonewton per millimeter squared unit. Newton per millimeter. Okay, next, average compressive stress in punch. When you consider in this punch, compressive stress, when you cut this area, then this area is given external force P is divided by A punch. Then this one is what? Stress punch. P is divided by AP equals what? Phi d squared over 4. Then the area AP can be calculated. Then finally you can get average compressive stress. Of course, unit is Newton per meter or millimeter squared. This unit you can calculate. Okay, so far we thought about punch and plate problems. Punch and plate problems. We dealt some selected problems, and I emphasize again, it's very important to solve problems carefully, and please solve problems with pen, not eyes. Thank you very much for your interest, and see you next time. Bye-bye. Bye-bye. Thank you very much for your watching. See you next time. Bye-bye.